All right, on today's episode of Python Papi, we're back inside our TensorFlow course, and we're still doing our malaria binary cross entropy loss module. Let's have a look at what we went over today. And yesterday, if you recall, we did some charting and some plotting of our predictions and our actual numbers. Today, we're going to run these functions here and see exactly what we get. So we started with the y actual or the y true equals 0, or the y predicted equals 0.8. Use the BCE equals TF dot correct dot losses binary cross entropy function. This is our output here, 1.60943. And you see it's reflected down here in our return here, 1.60943. Notice we get a value of 1.6. Now let's modify this. So let's say we have a y predicted of 0.02. As you can see here, we have a y true equals 0 and a y predicted of 0.02. We ran the same function, but just with those changed numbers. This was our return here, 0.020. As you can see reflected here in our 0.020. And notice that we have a return of 0.020. Now if we take the 0.02 and change it to a zero point 0.2, we'll have this. So let's go down. You can see we have a y true equals 0, a y predicted equals 0.2, same TF dot correct function, and this is our return here. We have a return of 0.2. As you can see, that's reflected down here, 0.22. Now we can always stack up outputs as we did in the beginning. So let's bring back these outputs. This time we're going to use multiple values for our true and predicted. For the true, we have 0, 1, 0, 0, and for the predicted, we have 0.6, 0.51, 0.94, and 0. We're going to use the same function here. We're going to run that, and we're going to get back this value here of 1.1007609. As you can see reflected here in the return also. This is because I already compiled it. I have these numbers already. That's why I just copied them from here and put them up here. So notice we have a value as a return. Notice the value we have as a return for our loss. Now also we can change the 0 to a 1 in our y predicted column, as you can see we did here. So we have a 1 here as opposed to a 0 we have up here. So we have a 1 instead. So everything is the same. We're just going to change that 0 to a 1 and run everything. As you can see, our return here is a lot larger number. We have a 4.9340760. As you can see reflected here, and the returns also down here. Now notice that this will increase the value of our loss. Now another argument we can pass in is the from logics argument. For the from logics argument, by default is actually false. Then the default value of false is supposing that the output of our model, the y pred, will always produce values in the range of 0 1. Now the way our model has been constructed ensures that all our values will be produced in that range because we have the sigmoid activated. And if we recall, with the sigmoid, as we increase the value of x, the output was going towards 1. So as we increase the value of x, the output goes towards 1. As x becomes very small, on the other hand, or take a very large negative number, x goes towards 0. So in fact, it's always going to ensure that the output lies between 0 and 1. That's why it's very important to have the sigmoid activated. Now, in a case where we don't have the sigmoid activated, our output doesn't necessarily lie between 0 and 1. What we're going to do is use from logics, the true, in our algorithm. Specifying this simply means that we are implying that we are not sure about the output of our model, always falling into the range of 0, 1. Now let's run our code below to see what we are returned. So we ran it. All we did was, it's the same numbers as we had with the 1. We changed the 0 to a 1. But this time in the binary cross entropy function, we use this parameter here of the from logics equals true. And as you can see, we got a return of 1.0227046. So notice that we will return a differently total response. So we have to be very careful when working with this. If the values range from 0 to 1, make sure we use a default from 0 logics equals false. So from here, let's go ahead and compile our model. So we did start compiling the model. I'm going to leave it there. I'm not going to move any further. We did take a lot more notes and we did do a lot more, but we're going to leave it here at the compilation because we're going to dive into that fresh tomorrow. But of course, I will keep you guys posted every step of the way. For now, it's the Python Papi. You guys stay Gucci.